Hello friends, myself Chandra Kumar. I am taking power electronics for the third year students. Under this, we are already discussing the various parameters which are associated with the power electronics, and today we are discussing about the firing circuit of SCR and triad. Exactly the meaning of the firing circuit means how to turn on the device, and there is the various techniques through which we can turn on the SCR. Then so under this heading, we are just discussing all these parameters. What are the different techniques we have that to turn on these devices? When designing a thyristor SCR circuit, special attention needs to be paid to the trigger circuit. The operation of the whole area of the thyristor or silicon control rectifier circuit is largely dependent upon the way in which it's triggered. Because whenever we have to just look over the thyristor or SCR, it indicates that when the SCR is turned on, because we have a limited time period under which the SCR must be turned on in case of the AC supply. If we are taking the AC supply and in Indian case, we have the 50-year sequence. 50-year sequence means the time period for the positive half cycle is 0.01 second. So before within that period, the SCR must be turned on. But as the time period will be increasing more than 90 degree, then the time period rest is 0.005. It means 5 milliseconds will be available to us to turn on to keep the device in under the on state. So our objective that to get the maximum power from the SCR. So at that moment, the triggering of the circuit is the most important parameter while the supply is AC. But when the supply is DC, then there is no problem because at that moment we have to just turn on the device and the device is under the on state until or unless we will turn off it. To ensuring that there are no false triggers while also ensuring the thyristor triggers when it is required needs to receive particular attention when the circuit design is undertaken. This will be the important thing that there is no false triggering signal will be given while we are not required the thyristor to be triggered. Within the triggering of thyristors or SCRs, various aspects, including the gate drive requirement, if gate triggering is used, trigger time where the time of the trigger stimulus applied needs to be maintained for the circuit to latch, and others are all important. The importance of the various parameters being dependent upon the form of SCR triggering used. In the part of the SCR characteristics, we are finding that the SCR will be turned on while we are looking over the latching current. If the current is more than the latching current, then the device will be turned on. To keep the latching current as close as to the source, then it will be it's better that we are getting the maximum efficiency while we are looking over the SCR. So there are several ways in which a thyristor or SCR can be triggered or fired. First method is the gate triggering. This form of SCR triggering is one that is most commonly seen in the different circuits used. It is simple, reliable, efficient, and also easy to implement for most applications. A simple trigger signal can be applied with suitable processing if required. This means that other electronic circuits can be used to drive a suitable trigger signal, and this can then be applied to the SCR. For gate SCR triggering to be used, the SCR must operate below its breakdown voltage, and a suitable safety margin also allowed to accommodate any transients that may occur. Otherwise, forward voltage or breakdown triggering may occur. To turn on off an SCR, a positive gate voltage between gate and cathode. This gives rise to a gate current where charges are injected into the inner P layer of the device. This effectively reduces the voltage at which forward breakover occurs. It may be gathered that the gate current determines the forward voltage at which the device switches to its conducting state. Higher the gate current, the lower the forward breakover voltage. There are many simple methods of applying the trigger signal. Possibly one of the simplest arrangement is shown as in the diagram that We have this one will be the supply. Supply will be given. There is a load. This will be the SCR. Then the resistance R1 and R2 are there. Here it can be seen that there are two resistors. First resistor is R1, which is included to limit the gate current to an acceptable level. This resistor is chosen to provide sufficient current to trigger the SCR while maintaining it within safe limits for the device. It can easily be calculated using the device ratings and the Ohm's law. R1 will be working as a limitation of the current which will be flowing through the circuit towards this point, and this current will be this R2 will make a path over in between of this one. So this will be limit or also this also limit about the current or the voltage which will be placed in between of this one. So the maintenance of the voltage and the current. Of course, the SCR is an important parameter just to make it in a safer zone. The second register R2 is gate cathode register. This is sometimes noted as RGK, and it is included to prevent spurious triggering. The action of the resistor can be seen with respect to the two transistor analogy of the SCR. It shows that a low external resistance between the gate and cathode bypasses some current around the gate junction. Accordingly, a higher anode current is required to initiate and maintain conduction. It is particularly found that low current, high sensitivity SCRs are triggered at very low current levels, and therefore an external gate cathode resistance is required to prevent triggering by thermally generated leakage current in the gate region. However, the gate cathode resistance bypasses some of the internal anode current caused by the rapid rate of change of the anode voltage (dV/dt). It also raises the forward breakover voltage by reducing the efficiency of the NPN transistor region, thus requiring a somewhat higher avalanche multiplication effect to initiate the triggering. The current that bypasses the gate junction also affects the latching and the holding currents of the SCR. It can therefore be seen that the effects of using gate cathode bypass resistor include: first, increase the dV/dt capability, retain gate damping to ensure the maximum repetitive peak of state voltage VDRM capability, raise latching and holding current level, lower the turn-off time. Although the simple circuit shown above is adequate for many applications where a more controlled triggering mechanism is required, account needs to be taken of the gate characteristics before triggering, during triggering, and afterward. This is required because the gate characteristics change as a result of the current changes within the device. Another method is the anode cathode forward voltage SCR triggering. This form of SCR triggering or firing occurs when the voltage between the anode and cathode causes avalanche conduction to take place. The way in which this occurs can be seen in conjunction with the SCR structure. When the cathode to when the anode to cathode forward voltage is increased, diode junction J2 comes under increasing stress as it is reversed bias. Ultimately, the voltage gradient will increase beyond the breakdown point and avalanche breakdown will occur triggering the SCR. The voltage at which this occurs is known as the forward breakover voltage or VBO. As the junction J2 breaks down, current will flow and triggering the SCR to its conducting state. The junction J1 and J3 are already forward biased, and therefore the breakdown of junction J2 allows the flow of carry across all three junctions, enabling the load current to flow. As with other forms of triggering, the SCR device remains in its conducting condition. The use of this method of turning the device on is not advised because exceeding the value of VU could destroy the device. Any circuit should be designed to avoid this method of triggering, noting the maximum of any likely voltage spike. Next method is the dV/dt triggering. SCR triggering can also occur without any gate current if the rate of rise of anode to cathode voltage exceeds a certain limit for the particular device. So by increasing the rate of change of voltage with respect to time, then the device can be turned on. But this method is not suitable as the previous one. Next method is the temperature triggering. This form of SCR triggering may occur under some circumstances. It may give rise to unexpected responses, and therefore its effect should be noted as part of any design process. Temperature triggering of SCRs or thyristors occurs as the voltage across the junction J2 and any leakage current may raise the temperature of the junction. The increase in temperature further increases the temperature, which will in turn increase the leakage current. This cumulative process may be sufficient to trigger the SCR, although it tends to only occur when the device temperature is high. But the this process is not applicable for the entire process because we have a limited time period for which we have to turn on the device, and then if the supply is AC then it will automatically turn on itself. So the time of the conduction period of the device it will be limited while we are using the temperature type of triggering. Next triggering is the light triggering. This form of SCR triggering or firing is often used with high voltage system. Here an electrical connection is not required from the firing mechanism and an isolated light source can be used. When light SCR triggering is also to be used, specially manufactured by SCRs are available. The light triggering occurs within the inner P-type layer. When this area is irradiated by light, free charge carriers are generated, and just like applying a gate signal, the SCR is triggered. To achieve the maximum light absorption, specialized SCR structures are used, often having a recess in the inner P-type layer to enable maximum access to the light. To enable the light triggering to take place, light is often directed to the correct point in the thyristor SCR using optical fiber. Once the light exceeds a certain intensity, switching occurs. An SCR of this type is often referred to as a light-activated SCR or lascar. These lascars have been used in high voltage power distribution switching centers. The optical switching enables very high levels of isolation to be achieved while still being able to switch with low level circuitry. So these it is particularly important to understand all the aspects of thyristor or SCR triggering. In this way, if any false triggers are experienced, then it helps track down the way in which this may occur. Also, if the thyristor does not trigger when required, this too can help resolve the issue. Thyristor triggering is one of the most interesting aspects of the design of circuit using these devices. If this area of the design can be successfully accomplished, then the remainder of the design should follow relatively easily. So this will be the concept of the thyristor firing, and what under this one we have found that the firing of the FCR will be more suitable by using the gate triggering method. So gate triggering method is the most preferred method which we are using to turn on any kind of SCR devices. Thank you for attending the lectures on the firing circuit of SCR.